Hi everyone, in this lecture we'll study access specifiers in inheritance. Till now what I have told you is like this is a class, this is class car, and here I have told you that whenever you want to practice you should put public here. But why only public? But we can put private as well and protected as well. So the concept is really simple. We're going to study this only, right? And let's start. In C++ inheritance, actually we can make, for example, there is a parent class. For example, this is a parent class, and now this is a child class, right? And we want to make, basically we can make child class in different access modes. That those access modes can be private, public, or protected, anything you want, right? So what is the meaning of this? What is the actual meaning to put private, public, or protected here? So to understand this, let's take an example. For example, this is a class vehicle or any class. It has a member function or a data member like ABC or something, name or something like that. So whenever a child class will inherit this class, right? Whenever a child class will inherit the parent class, it will have access to the properties. What I mean by access here, virtually the name will be included in this class. We will not declare it explicitly, but internally when the child class inherits the parent class, that the data member of the parent class gets included in the child class. Now whenever we explicitly declare the member functions or the data members in any class, we make under some access specifiers, like what access does that member function or data member have, right? For example, if I declare a class, if I declare data member as name, I have put it inside the public, so it will have the public privileges, right? But since this name is virtually included in this child class, what access does this name have? What access the name data member will have in this class is the access mode in which the base class will be inherited. Let's take an example. For example, there is a class vehicle. Now in this class vehicle, there are different member functions like number of wheels, and that wheels is a data member, right? And inside the class, this will be public, right? Now we create a subclass, and the name of the subclass is car, right? And we inherited it. Now we inherited it, and since it is the public, the number of wheels is under the public access specifier, virtually or internally the car will also get the data member number of wheels, right? For this car class, should the number of wheels should act as private, should act as public, or should act as protected? We cannot directly declare it because inside the class, because we are not explicitly defining the number of wheels. We are not explicitly defining this data member, but how to give the access of this data member or properties in this class, and that's where the access modes come into the picture. Let's write a code snippet Now if I want that inside this car class this data member should be publicly available, then I will give it as public, right? Now if I want that, okay, for this car class the data member should be private, then it will be private, and similarly for protected it can be protected. So basically access modes define the access of the data member in the child class. Or more precisely I would say the access modifier will define the access of the inherited properties in the child class, right? So the whole concept is this. It's for this point of time you may found it a little bit complex or something like that, but believe me, it's not. It's really simple. When you if you're doing practice, then it should not be that tough for you at this moment, right? The whole concept is really simple. Now what access modes actually do? Access modes actually create another level of access control. They are basically giving you the access of the data members and member functions in the child class, right? And what is the need of that? You can say that there is something as public, but you don't want your child class, the members of the child class, to access those things directly. Then you can make the access mode as private, right? They will not have the access of your things directly, right? So here is a table. To make it more clear, base class access specifier means this, which is the base class access specifier, and this thing is as what you can say access mode in which the base class is inherited. Right. So if the base class access is public and the access mode is also public, then in the child class it will be public. If the access mode is protected, then in the child class it will be under protected access specifier, and if it's private, then it will be under private. Now if the base class access specifier is protected and in access mode you made it as public, then it will be protected. So the thing that we have to share it is C++ takes as the take if there are two access specifiers, one is protected and one is public. C++ will take the access modifier with the lowest level of accesses, right? Here is protected and public. The C++ will take as protected access specifier, will make the access of the member functions as protected, because if it be public here, then it will violate it, right? Similarly, if it's protected, then it will protect it, and if it's private, if it's protected and it's private, then in the child class, the member of child class will have the access, but it will be private only, right? And if it's private only, then there is no way the child class will have the access, right? So it's not accessible. So it's pretty much simple. So let's write a program for this. C++ in implementation to show that the derived class doesn't inherit access to private data members. C. This is class A. Int x is public, y is protected, and the z is private, right? So if I inherit a class B in public mode, right? I make a child class as B and inherit class A. X is public, y is protected, and z is not accessible, right? If class C is inherited, means class C is the child class and make the class is inherited in the protected with the protected access mode, then X is protected, Y is protected, and Z is still not accessible from C, right? And when it's private is basically default for classes, right? So X is private, Y is also private, and Z is not accessible from D, right? And let's say let's paste this whole program here, right? Let's do it. Okay, let's include the library. Let's make the objects of class A, B, not A because A is the parent class, right? And class B, class C, and class D. So let's try it. B class will try to access XYZ, C class will try to access Z, and D class will try to access XYZ, right? And let's see, it should give an error because see, Y class, in Y class it's protected, and with protected you cannot access directly with an object. So here B.Z is private, Z is already private, we cannot do it here. Let's see now. Yeah, A.X is inaccessible in this context. C is under the protected, right? So X is also protected and Y is also protected. So we cannot access this using the object. And since D is in the private, we cannot access it. Using object, definitely we cannot access it, right? And C, access 0. So that's the thing. In class, basically, if you know, in class the integer is basically default value, is not garbage value, it's 0, right? And I guess you are able to understand and get some hang of what I'm trying to say. Let's think of an example. In simple terms, to understand more about the need, what access a public member from function will have in the child class, will it be public or private? The answer is obviously access modes. That's the thing, right? The members of the class inherited in public class will have the public access in the child class. Similarly, the members of the class inherited in public or protected mode will have the respective access in the child class. Inherited in private mode will have the private access, and inherited in the protected mode will have the protected access. And we have seen the same in this program, right? So I will share this whole program, this C++ code with you. Just try to do some all permutations and combinations, right? Because the more lengthier the lecture will be, the more boring it will be, right? I actually want you to practice on your own. I want to clear your doubts, because in IT industry there is no place for spoon feeding. The client gives you a project, it's your project, right? It's your task. If you're not able to complete it in 6 days, they can give you maximum to maximum 1 more day, right? So that sort of thing happens in the IT industry. Means don't expect spoon feeding there, and that's why I am asking you to just practice on your own. Try to do all permutations and combinations, and I'm giving you the most simplest example so that you can think of more and more complex examples on your own, right? Just keep your inner child alive and be more curious, right? So this is the whole topic of access specifiers in C++. I hope you understand the meaning of public, protected, and private. These are really simple things. Just practice it. Study this. The more you practice it, the more you learn about this, the more things will become more sorted and simple to you, right? So that's it for today. If you have any doubts, then please ask us, please, because these are really important. So that's it for today. We'll meet in the next one. Thank you.